Today our lesson about sets of zeros of the polynomial function. To get the polynomial function for the set of zeros, we must make f of x equals 0. So we want to have the set of zeros of this function. The set of zeros is depended on by factorizing this equation into two parts, or as we studied before, anything that we study about the polynomial function. So to get this x, we must substitute it in this equation. We find that it will be equal C0. So our solution, it will be the set of zeros depend on this substitution. Like this example, to find the set of zeros of the polynomial function, we must have the equation. So our equation, it will be equal the function 0. So x power 2 minus 3x minus 10, it will be equal 0. So by factorizing these numbers, so we get the two brackets x minus 5 and the another bracket x plus 2 equal to 0. So the first bracket, it will be equal 0. So x, it will be 5, and the another bracket, it will be x equal negative 2. So the set of zeros, it will be 5 and negative 2. Another example, f of x equal 2x to the power 2 minus x minus 3. So by making this factorize equal to 0, so 2x minus 3 equals 0 and x plus 1 equals 0. So our values of these zeros, it will be 3 over 2 and negative 1. So if we have equation like this, x power 2 plus 2x equal 15, so we want to make rearranges for the term to make our factorize. So x power 2 plus 2x minus 15, it will be equal 0. By making factorize for this expression, we get x plus 5 and x minus 3. So x plus 5, it will be equal 0. So our answer for this x, it will be negative 5. And another one, it will be the inverse of negative 3. It will be 3. So our sets, it will be 3 and negative 5. So this is the solution set for this value. When you substitute 3 and negative 5 in the function that we have, so we will find that the equation, it will be equal to 0. From the previous, we wanted to get our domain. So our domain, it is depend on the values. So to get the domain, it will be depend on the all real number except the set of zeros. So our denominator, it will be equal to 0. So there is no solution for this function. And the common domain that we have, we want to have a denominator for domain of the first function and the domain of the second function. Then we get the intersection between the two set of zeros of these two domains. Like this example, the domain of the function x minus 3 over x plus 2. So we want to get our set of zeros for the denominators that we have. So x plus 2 equal to 0. So our x, it will be negative 2. This value of negative 2, if we substitute in this function, we get the denominator, it will be 0. So our result, it will be undefined. So the domain of this function, it will be r except negative 2. For this function, it will be by using substitute for 0 and negative 1 and negative 2. So we can get n of 2 not getting our value, but for 0 and negative 1 we have a value. So another example, it will be n of x depend on x minus 5 over x to the power 3 minus 8. So by making the denominator, it will be equal 0. X power 3 minus 8 equals 0. So our x, it will be 2. So the set of zeros of the denominator, it will be 2. So the domain, it will be r except 2. To get the common domain of each of the following function, we have two functions here. So our function, it will be x power 2 minus 9, it will be equal 0. So our solution set for this is the difference between two square. We have to answer 3 and negative 3. So our first domain, it will be R except 3 and negative 3. And the another one, it will be the factorizing for x power 2 minus 5x plus 6. So we have two solution here, it will be 2 and 3. So to get our common domain, it will be R except the intersection between two sets, 3, negative 3 and 2. And this is the last example in this lesson. Thank you for watching this video.